Yeah, so joining camp, so let's start off. Chalo, camps on everyone. Where are the rest? So last class we are doing flux. So if you keep a charge Q inside and a charge Q, doesn't matter where you keep it. We proved last time that for any random surface, the flux will be Q by epsilon. Others camps on. People join late and then they cry. See. So from here means we can do something more also. What happens if you keep charge Q outside? If you keep charge Q outside, what happens? Now, if they ask a question like this, one thing is clear. If a charge Q is inside, the flux is Q by epsilon. If charge is outside, then what happens? So if we observe, the number of lines entering the surface is equal to number of lines leaving the surface. The number of lines entering is equal to number of lines leaving. Therefore, the flux through the entire closed surface is zero. Is this making sense, everyone? Clear with this? Reina, Hashni, clear, na? Abhiksha, Gauri? So we keep a charge key outside, whatever lines enter. Remember what is flux ka definition? Flux ka definition is number of lines crossing an area. If the number of lines entering is equal to number of lines leaving, then there's no number of lines, that is net number of lines is zero. So total flux is zero. Now here they'll ask something important here. So examiner, they'll ask this question only. They'll say a charge q is placed outside, the flux at a point. Is this zero? Is this positive, negative, or zero? The flux at a point, flux on the closed surface are totally two different questions. If you observe this, at this point, this is the area vector. At this point, this is the area vector. At this point, this is the area vector. And if you look at the field vector, here the field vector is like this. So if you see this angle is acute. So the flux is positive, E dot dA. Here both are 90 degrees. So when there's a tangent, so flux is zero. At this point, this angle is obtuse. So flux is negative. So be careful with this thing. So flux at a point can be positive, can be negative, can be zero also. But the total flux is zero. So what happens right in the exam, they'll say like this, a charge Q is placed outside, find the flux at a point. Everyone remembers this statement. Sir told if the charge is outside, flux is zero. If the charge is outside, total flux is zero. Flux at a point is not zero. At every point there's a flux, which is positive, negative. The total sum is zero. So two important things. So one thing, if you're inside, flux is Q by epsilon. If you're outside, total flux is zero, but flux at a point is can be positive, negative, or zero. Please check. Why people are not joining? Previous slide, last class, day what we did. Check. Clear, Gauri? Have a look at this, everyone. Shaurya, cams on. Kavya, Divyanshu, cams on. Others finish your dinner and switch on your cams soon. Why people bunked so badly today? Clear with this, everyone? Let's see some questions on this. So this is basically a very important idea there. You did projected area, no? Great. So if you keep a charge Q here, and if you have a disk here, and this angle is theta. Find the flux passing through the disk. Rhythm, you're late, and top of it, you don't even keep the cam on. Divanshu, what happened today? Why so late? There is a reason, or just like that, you guys just don't care, like you can think you can come anytime? Rhythm, Divanshu? That you should tell me before the class started, right? After the class started, you tell me, I'll think it's an excuse. What is the answer for this thing? It's a good one, people. You have a point charge Q at a certain distance. It is making an angle theta with the upper part of the disk. Find the flux passing through the disk. This result is more important. Remember the result. Let me show you how it is done. Q by 2 epsilon 1 minus cos theta. This is the flux passing through the disk. So how did we get this? See, if you take a part of a sphere, can you observe something here? Every line that passes through the sphere passes through the disk. That means the flux passing through the disk should be equal to the flux passing through the curved surface. So flux passing through the curved surface is equal to flux passing through the disk. And do you guys remember the area of a part of a sphere? I told you multiple times to mug up this result.
Theta 1 minus 2 pi r square.
So area will be 2 pi r square into 1 minus cos theta. This is the result which you have to remember. We encountered this question in friction. Optics, this is the third time. You'll see this again in modern physics. This we did in calculus. You can refer there. So that means for an area 4 pi r square full sphere, what is the flux? For full sphere, the flux is q by epsilon. For this much area, what is flux? Unitary method. Isn't it? So the flux passing through the disk will be the ratio of 2 pi r square 1 minus cos theta by 4 pi r square q by epsilon. Q by 2 epsilon 1 minus cos theta. Check. The idea was this. How did we do the derivation for this? You can check it out in calculus. I showed you how to find the area for this thing. Calculus 4th problem, page 108. You can refer the calculus notes how we integrated this. Have a look at this. It's a good one. Now, how can they frame questions on this? Got the result, no? Now see, the question will be like this actually. We have a charge Q1, we have a charge minus Q2. A field line leaves Q1 and enters Q2. It leaves Q1 at an angle alpha. It enters Q2 at an angle beta. So we have a field line which is going from Q1 to minus Q2. It leaves at an angle alpha and enters at an angle Q2, angle beta. Find relation between alpha and beta. So we have two charges, Q1 and minus Q2. A field line leaves from Q1 and enters Q2 at an angle alpha and beta. How do you find the angles between them? The relation between them. Try. This and the previous one are kind of related. This is how they'll frame questions in advance. Listen, the idea is a little different. What we do now here, consider a disk like this. Consider a disk like this, meaning the disk is very close to it, okay? I'm just exaggerating the figure here. So from this, you can observe every line that goes from this disk to that disk is same. That means flux passing through this left disk will be how much? Q1 by 2 epsilon 1 minus cos alpha. Flux passing to the second disk will be Q2 by 2 epsilon 1 minus cos beta. Since the number of lines are same, flux 1 is equal to flux 2. This will be Q1. What is 1 minus cos alpha? 2 sine square alpha by 2. This will be Q2 into 2 sine square beta by 2. This is the relation between alpha and beta. Easy? But to do this, you need to know the previous question ka result. Without that, you can't do this. Is everyone clear with this? There, you can even find the angles made by the field lines also. Clear? Next one. Same question. This is even better. We have a charged disk. Sigma is the surface charge density. So it's a disk of radius r. From the center, at a height, you kept a charge plus q. Theta. So the question is, now see, this charge is what? Plus, right? This charge is made of positive charge. Radius is r. The plus q charge is also positive. So won't the two things repel each other? The positive charge and the positive plate will repel each other, right? Find the force between them. This question you can put a star that discuss thing. Meaning you have some pretty good different concepts here. How do you find this? There are two ways to do this. One, you can actually find the why will force be negative? They'll repel each other. Both are positive. One way to do this thing is you can find the field due to the disk. Remember field due to disk formula? What is the field due to disk formula? Who will tell me? Those who don't remember field due to disk formula, you're a Godzilla. Who don't remember? Everyone is a Godzilla here. Everyone remembers field due to a disk. Sigma by 2 epsilon 1 minus cos theta. Remember? Don't forget. Now, but listen to this technique, okay? This is much better. You can do that way, but the technique I'm teaching you is useful for this thing. When you take this disk and you have a plus q charge here. So from this point, let's say if you take a small piece here, the electric field is acting this way. Agreed? This will have a small area dA. Now by symmetry, if you observe, the electric field is this way. Which components will cancel out? The E dq sine theta, that is a force component. This will be E dq cos theta. This will be E dq cos theta, and this will be E dq sine theta. So if you see here, horizontal components cancel out. Does that make sense? Because by symmetry, for every one point, there's another point where the horizontal components cancel out. So the net force will be integration of the E dq cos theta, the vertical components. Make sense? But what is dq? Sigma into that small area into cos theta. Sigma is constant. E dA cos theta. But what is E dA cos theta? Sigma E bar dot dA bar. What is E bar dot dA bar? Flux. So the force acting on any surface is simply sigma into flux of the disk or flux of the surface. So from our question, force will be sigma. What is the flux? Just now we calculated it. Q by 2 epsilon 1 by cos theta. Easy. So we actually manipulated the Gauss law equation to give us force. You can do this for any random surface. Huh? Even if you have some amoeba shape, and if you have plus Q, so this will have two components, F vertical, F horizontal. The F vertical is given by sigma into flux passing through the surface. That how to calculate, we don't know. Fx, this can't be calculated. So you can apply this for any type of surface. The problem is you should be able to calculate the flux. And symmetry hona chahiye. If there's no symmetry, Fx cancel nahi hoga. Are you clear with this thing? So this is a more general formula. Force will be sigma into flux passing through that. Have a look at this. Let's see one more question like this. Clear? Let's see a question like this. Vrinda, clear so far? So people say there are three concepts in this. Flux passing through the disk, the relation between the angles in a field line. The third thing, force on a disk. Suppose same question if I ask you like this. We have a square plate A. Density is sigma. You kept a charge Q at a height of A by 2. Find the force between them. What is the formula? Just now we derived sigma into flux passing through the surface. So you have to find the flux through the square plate. So somehow if you can find the flux, your job's done. So what do we do here? If you take a cube, remember one thing, in a closed figure, flux is Q by epsilon, that much we know. And here, luckily, if we see, the charge Q is at the center of the cube. The charge Q, if you make a complete cube, it is at the center. What is the flux through the cube? Q by epsilon. Agreed? How many faces are there? 6 faces are there. So what is the flux through each face? 1/6 of Q by epsilon. Agreed? So what is the force? Sigma into flux through each phase. Sigma into Q by 6 epsilon. Easy. Make sense? Complete the cube. Total is Q by epsilon. There are 6 phases. So Q by 6 epsilon. Force is sigma into Q by 6 epsilon. If you try to integrate and do, you will die in this. But then again, instead of a by 2, if I keep a by 3, you can't solve. Symmetry hona chahiye. If it is a by 3, you can't solve because the flux won't be equally distributed for all the phases. Is this clear, everyone? This model is a good one. The force part is pretty good. Any doubts on this thing? Please ask. Reina, clear? Reina, clear? Amu, clear? Trisha, Vrinda, Divyanshu, Rhythm, you need to adjust your camera. If I can't see your complete face, I'll remove from the classroom next. This is something every time I keep telling you. Don't make me repeat. Do something. If I need to see your full face, everyone. I don't want to see just your eyes like a Batman or something. If I can't see your full face on the screen, I'll be just removing you from the classroom. Next one. Let's say we got a cube here. We have a charge Q in this corner. This is phase 1, phase 2, phase 3, phase 4, phase 5, and phase 6. So plus Q is at the corner. Find the flux through each phase. Q is not inside, Q is not outside. It is just on the corner dot. How much flux will pass through each phase? 1, 2, 3, 4, 5, 6. Try. This is a good one. Which phase? 1, 2, 3, 4, 5, 6. Every phase. There are 6 phases. First thing, can you find the flux passing through the cube? See, if you take a cube like this.
1/8, 4 to
1/8, no? This thing, did you study in solid state chemistry? An atom in the corner will contribute 1/8. Did you remember that solid state chemistry? An atom in the corner will contribute to 1/8. So since there are 8 cubes, so flux through the big cube will be Q by epsilon. So flux through that small cube will be 1/8 because there are 8 of them. Right? Now look at this thing here. Whichever faces, right, the charges, whichever faces touch the charge, look at the field lines. The field lines are like this. How is the area vector? Perpendicular to the plane. They both are perpendicular, right? That means the faces which are touching the charge, the face in contact with the charge, has E bar parallel to surface. That is, field is perpendicular to A. Therefore, flux is 0. So in our cube here, one, two, three, 4, 5, and 6. And this is your point charge here. Which faces are touching? 3 is touching, 6 is touching, and 2 is touching. They're 0. The other 3 guys, flux 1, flux 4, and flux 5, right? That will be 1/3 of q by 8 epsilon. Because the total flux in the small cube is q by 8 epsilon. That is shared by 3 people. Please check. It is not 1/6 of q by 8. The 3 faces which are touching will have 0 flux. The other 3 guys will take equally whatever is coming. Q by 8 is coming through the entire thing. So it is 1/3 of q by 8 epsilon. Clear? So it is important like which face is getting flux. You just can't divide by 6 every time. Symmetry भी देखना पड़ेगा. Please check. All clear with this? Same question, if I can extend it a bit. This is what I was saying last class. Gauss law, did you say it is all about statements? There is no numerical nothing. Statements se prove karna padega. That has no relation ratio. Okay. Only symmetry तक है. उसके बाद कुछ ये नहीं है. Same question. We have a cube. Let's say we have an infinite line charge. Lambda . One, 2, 3, 4, 5, 6. Find the flux through each face. So we have an infinite line charge passing through one side. How do you do this?
Sir, are we given the length of the cube?
Side is A.
Okay.
Side is L. वो चाहिए तो चाहिए. You'll need it. Again, if you see the logic there, the infinite line charge is like this. How are the field lines? Like this, na? Means any surface that touches the line charge will have 0 flux again. This is A bar, this is E bar. The flux is 0. So who all are touching here? 1, 3, 5, and 4 are 0. So meaning the only ones left are 2 and 6, right? 2 and 6 का कैसे calculate करेंगे? If I make 4 cubes like this.
So we can draw the diagonal?
Diagonal nahi hai. Wait, I'll show you how. You have to always make a closed figure, Reverenda. So you want to make this a line charge, right? So I'll construct 3 more cubes. Able to visualize? So for this 4 cubes, what is the line that is stuck? This line, na? How much charge is that? Lambda into L. So what is the flux through the 4 cubes? Lambda L by epsilon. So what is the flux through each cube? Lambda L by 4 epsilon. Does that make sense? That line which is passing through one side, you put 3 more cubes. So ये center में हो जाएगा ना, this part. This is a charge enclosed. So basically you always have to make a figure which is charge enclosed. Is that fine, everyone? Sure with this? What I did?
So I was thinking like maybe you can draw a diagonal from one side of the cube to another. Then
Diagonal, like this.
something like
And
that.
then what will happen?
Then we could have find like the length of that. No, that's not.
What will you do with it? You need to find charge enclosed by epsilon, na? Is that clear? And here, so who is the flux here? So flux 6 and flux 2 are there. They will, whatever flux you have, they'll take equally here. So flux 6 and flux 2 will take half of this flux. Is that making sense, everyone? So basically, you always have to find, first of all, this line charge will give how much flux to the cube. See, all the lines won't pass through the cube, right? They'll spread out. So whatever lines are passing, why 5 is 0? Because 5 is touching, right? 5 is this guy, 5 is this space. It is touching the line charge. All clear with this? Good one. Actually, you could have guessed it like this also. If you look at the top view, this line charge which is there, field lines will be like this, no? In this part, the cube is occupying 1/4 of the space. So this angle is 90 degrees. So 360 degrees will give you q by epsilon ka flux. So 90 degrees will give you q by 4 epsilon. Q is nothing but lambda by 4 epsilon. Is that easy? If you have a line charge, the field lines are going in 360 degrees. 360 degrees will give you q by epsilon. If you keep only one cube, it is covering just 90 degrees. So it will take 1/4 of the lines, right? This is easy. So you can use whichever you want. You can put 3 more cubes and make a closed figure. Or you can simply say 360 degrees mein flux is q by epsilon. Since the cube is occupying 1/4 of the angle, so the flux should be 1/4 of q by epsilon. And q is lambda into L. Sure, everyone? That. So flux calculation ka problems will look like that. So it's all about symmetries. Next thing, Gauss law. So actually kind of we proved Gauss law first. So the reason why we do this, right? Gauss law is more, it comes first actually. People, first Gauss law came first and then came Coulomb's law. But Coulomb's law is more powerful. Gaussian surface. So let's define this. So you can do everything that you did with Gauss law with Coulomb's law. But with whatever you do with Coulomb's law, you can't use Gauss law. Gauss law is only useful for symmetrical surfaces. We will see how it works. So what is a Gaussian surface? A Gaussian surface should be a closed surface on which electric flux is calculated. So what Gauss law states is, we will not go to the definition and all, we'll keep it simple. Just write it down. The flux through a Gaussian surface is 1 by epsilon times charge enclosed. Flux will be integral E bar dot dA, which is equal to Q enclosed by epsilon. Ironically, we already proved this using Coulomb's law. We put a symbol like this. The meaning of this symbol is closed integral, means you're integrating over a closed surface. Clear? This is the basic, right? We already know this thing actually. The flux encloses Q by epsilon. Now, let's see theoretically what it means. So when you write the statement here, let's say we have a surface here. On whichever, see, Gaussian surface is something random. You can choose anything as Gaussian surface. Wherever you calculate flux is called Gaussian surface. Okay? So let's say we have charges like this thing, okay? Q1, Q2, Q3, and Q4. Now what Gauss law says is integral E bar dot dA, that is the total flux on the entire surface, is Q enclosed by epsilon. So the Q enclosed here will be, what is the Q enclosed here? Q2 minus Q3. So the total flux is only due to the inside charges. This E is actually due to all charges. E bar is due to all charges present inside and outside. This is a theoretical question in the exam. Then you might be asking, sir, but you're saying flux is, you're taking only due to inside charges. Why are you taking field due to everyone? Do you remember just now we proved something? If a charge Q is outside, what is the flux? 0, right? So what is actually happening now? When I split this integral, E bar is actually field due to E1, field due to E2, field due to E3, and field due to E4. When I substitute and integrate, I end up with E1 dot dA, E2 dot dA, E3 dot dA, E4 dot dA. This is equal to total charge enclosed Q2 minus Q3 by epsilon. But these two will be 0, right? Anyway, because the charges are outside. Q1 and Q4 are outside, so flux is 0. So what you're doing is simply you're adding zeros to the function. Are you getting this thing? Now, why did this happen? See, when Gauss was doing this experiment, right, you cannot calculate field at a point due to only individual charges. No? Whatever field you'll get will be due to all the charges. But when he calculated the flux, he's getting only due to the inside charges. So just remember this theoretical question in the exam. In Gauss law, what is Q? Charges enclosed. What is E? E is due to the all charges inside and outside. Clear with that? So generally what people think is, if you're taking inside charges, why are you taking outside charges ka field? The reason is the outside charges ka field will give you anyway 0 flux. So it doesn't matter whether you take them or you don't take them. Is this clear theoretically? So what is the big deal about this Gauss law actually? So let me show you some. So Gauss law is useful to find electric field due to symmetrical charge distributions. If you have a symmetrical charge distribution, it is useful to find the field. Let me give an example. Now, for most of them, you already know the results. If you have an infinite line charge, what is the field due to infinite line charge?
2k lambda by d.
2k lambda by d. Some of you are not revising the notes. Major test are at 3 weeks, man. Then you will cry, sir, marks we got less. Thing is, you should cry because you didn't do the work, not because you got less marks. Now see how to do this thing. Step 1. Choose a symmetrical Gaussian surface. Step 2. Calculate the flux. Step 3, use integral E dot dA is equal to basically that only, flux is equal to integral E dot dA to get E. Let me show you how to do that. So first thing, so for an infinite line charge, what will be a good symmetrical shape? A cylinder, right? Right? Cylinder is a symmetrical shape. Why is a square not a symmetrical shape? What is the problem with this? If I take a cube like this, why is this not symmetrical? Anyone?
Diagonals and the side are different.
From here, अगर ये distance कितना होगा? A by 2. What is this distance? A by root 2. All are different distances, na? So you need to keep them in such a way all are equidistant or they look identical. So here, how is the field here? Field is this way, E bar, E bar, E bar, because the field will be radial. And how is the area vector? Area vector will be like this for this upper part. Here area vector will be like this. Here area vector will be like this. So here the flux will be, flux in the cylinder will be flux on the two discs. Upper plus flux on the lower disc plus flux on the curved surface. This is 0, this is 0 since E is perpendicular to A. The flux on the curved surface E is parallel to A, so E into surface area 2 pi R into L, where R is the radius of the cylinder and L is the length. So far clear? So we have flux is equal to E into 2 pi R into L. This is equal to charge enclosed by epsilon. What is the charge enclosed? Lambda into length by epsilon. LL will cancel. The field will be lambda by 2 pi R epsilon or 2k lambda by R. Got this? So without any integration, without doing anything, you'll get the answers. But problem एक ही है. If it is a finite wire, you can't solve this, right? If it is a finite wire, we don't know how will the field be. Field won't be radial. So you can't solve these problems for non-uniform distributions. Got the logic here? Let me show you one more. This result is important. We didn't do in electrostatics or gravitation. Hollow charged cylinder. So we have an infinitely long hollow cylinder. Radius is R. The entire surface is having charge sigma. This can be asked in the exam directly as a question. Huh? So first thing, for R less than R, meaning inside, consider a Gaussian surface. So I will take a Gaussian surface like this. What is the flux? Let this radius be small r and let this length be L. Flux will be field into 2 pi R into L. Agreed? But what is the charge inside this cylinder? This is 0, right? Because it is hollow, no? There is nothing inside. Are you getting it? It is hollow, there is nothing inside. Therefore, field is 0. So inside a hollow cylinder, field is 0, just like a hollow shell. For R greater than R, that is outside. Again, consider a Gaussian surface like this. The flux will be E into 2 pi R into L. This is equal to Q enclosed by epsilon. Now, what is the charge enclosed? This part, right? Which is sigma into the surface area, 2 pi r into L. So E into 2 pi RL will be sigma into 2 pi RL by epsilon, 2 pi L cancels off. E is equal to sigma R by epsilon into small r. So if you actually plot the graph for E versus R, this graph looks exactly like hollow shell ka result. Constant and 0 and then decreases. So for a hollow cylinder, outside it behaves like a point, like an infinite line charge. This is the formula. Field is 0 inside. Sigma capital R by epsilon small r. There, this result we didn't have it in electrostatics or gravitation because integrate करके निकालना बहुत difficult था. So this is how you use Gauss law. You can take a Gaussian surface inside, outside, flux is equal to Q by epsilon. From there you get field ka values. Check. All got this? Same thing can you do for this thing? Uniformly charged solid cylinder. So we have a solid cylinder. Now it is uniformly charged, means charge is everywhere. This is radius R, and can they find the field inside and outside? Rho is the volume charge density. Same idea. You'll take a sphere inside, but this time inside will not be 0, no? This time, this red guy inside there will be some field charge, right? That won't be 0. Try. This is a good one. Field due to a hollow cylinder, solid cylinder. Now, so you have many shapes, huh? You have a finite wire, then you have arc, then you have shell, solid sphere, hollow shell, infinite sheet, disc, dipole ka formulas, and now the 2 cylinders. I'm telling you again, if you can mug up all the formulas, it will be quite easy. Electromagnetism is one of the favorite chapters of medical students because there are a lot of formulas. Unlike mechanics, now you need not use your head too much. You get some standard results. If you can just mug up entire electromagnetism around 30% weightage. Most of you will lose marks because you're too lazy to remember the results. And the standard models, whatever I'm doing, pretty much they don't go out of this. If you can handle this much and if you finish your HCV and whatever papers you are doing, more than sufficient. Get this, how to do this thing. Try, I'll give you a minute or two. show you. Step 1, take a Gaussian surface inside. This is small r, this is length L. So for r less than r, the flux will be only due to the curved surface E into the surface area, 2 pi r into L. This is equal to charge enclosed by epsilon. Charge enclosed is rho into volume because rho is volume charge density. Pi cancels off, you end up with rho r by 2 epsilon. Yeah. For r greater than equal to r means you're taking the cylinder outside now. The problem when you take a cylinder outside, charge is only till this part, isn't it? You can't take the full charge. Charge is stuck only till capital R. You don't have a charge after capital R. So this time the flux will be, the LHS will be always same, right? E into 2 pi RL for cylinders. The right side Q by epsilon, this Q will get stuck now. Pi capital R square L by epsilon. So this will be rho R square by 2 epsilon small r. So if you actually plot this on a graph, this graph looks like a solid sphere ka result. Did you observe? This is a linear function proportional to r, and then it decreases. It looks like solid sphere ka result. So the field inside is proportional to r, field outside is proportional to 1 by r. Please check. Hollow sphere and solid sphere ka results. Clear with this? Same way, if you take a solid sphere uniformly charged, which we know the result already, let me show you that. But have a look at this page. Any doubts, please ask me. Anyone not convinced, not clear? Clear? Now see, I'll show you one problem. I'll ask you something similar. You try. Uniformly charged solid sphere. So if you have a fully charged solid sphere, let's say plus Q, radius R, and I want to find the field inside and outside. So in this case, what I do, first I'll take a Gaussian surface inside up to small r. Now remember, this is a solid sphere. The flux will be E into area. Area will be 4 pi small r square, na surface area. That is equal to charge enclosed by epsilon. What is the charge enclosed? Density will be Q by 4 by 3 pi r cube. So this will be rho into the volume of that small sphere, 4 by 3 pi r cube by epsilon. This turns out to be E into 4 pi r square. This will be Q small r cube by r cube epsilon 4 pi. So this will be E is equal to KQ small r by r cube. Isn't this the formula inside a solid sphere? K is 1 by 4 pi epsilon. Similarly, if you take a Gaussian surface outside for r greater than equal to r, the flux will be same thing, E into 4 pi r square, but this time luckily entire charge is inside. So E will be directly Q by 4 pi epsilon r square or KQ by r square. This was the result, right, for a solid sphere inside and outside. This is a proof. Solid sphere ka results. Do you guys remember? So if you actually plot the graph of E versus R, this is how it was looking. It was a straight line, 1 by R function, and then there's a 1 by R square. Sure. What is the question they'll ask in the exam? But please have a look at how I took. So for a solid sphere, the Gaussian surface will be hollow shells. You take a shell inside, shell outside, and then find the flux and equal to Q by epsilon. How more clear with this? Reina, are you getting this? Akka?
Yes, sir.
Nishita? Ritam? Sure so far? Sure, Ritam?
Yes, sir.
Dipanshu? Danya? Hasni? Clear? Kavya? Now, what I want you to do is this one. What is the last question number? 7. Na? We have a sphere where rho is equal to rho naught into r. Constant nahi hai, means it is increasing with radius. The more you go outside, more charge you have. For r less than equal to r. Rho naught is a constant. Means if you look at the charge distribution, it is increasing, 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 increasing. Are you getting how it is? As you go outside, the charge is becoming more and more. Find the electric field. Find the electric field as function of R. This is a volume charge density. There is a kind of symmetry. For a given circle, for a given sphere, this entire sphere will have same charge density. So mains exam is asked this question. Rho is equal to rho naught R, then field is proportional to R power what? They asked for power actually. Let's see. Let's do for this, then I'll show you a general solution for R power n. Think how to do this thing. Did they finish off Gauss law in the pace? It's going on. And did they start surface tension, viscosity? Khatam ho gaya? Going on. Going on. I think let's see. After Gauss law, I think we can do viscosity and then dekhte hain wo log kya kar rahe exactly. Viscosity or surface tension. I think major iska portion aaya na. They have capacitors, everything is there. So when they say properties of matter, is the elasticity there or not there? You don't know.
I think it's there.
Confirm that once, whether elasticity is there. Normally it should be there. Let's see. The problem here, it's a gamble for us, which chapters to do first. It shouldn't happen like we finish one chapter and then they cancel the chapter. How do we do this? Let's finish off Gauss law, then we'll finish off viscosity, surface tension, then we'll come back to capacitors. I think that might be safe. Gauss law, viscosity, surface tension, small chapters only. इनको लगेगा. Yeah, properties of matter मतलब वही होगा. Surface tension, viscosity, and elasticity. वही बोल रहा हूँ. Let them keep, no. Let's at least you finish off whatever we are doing, right? You finish those chapters properly. Let's not run behind the portion. वो एक दो chapter जाएगा. Let it be, ना. Who is asking you to score 100 out of 100? Just score 85. Sufficient. What do you think? See, I'm being so gentle. Summer offer 80 लेके आओ काफी है. What do you say? 5% discount. How to do this thing? That's a final target, right, gods. हंसना मत. Next year JEE mains में you guys need to score at least 75 plus in physics, which is quite possible. If the paper is like last 3 years, na, आराम से you'll score 80 if you just finish all the notes, previous year questions properly, and you write all the papers I'm conducting. 80 plus easily आएगा. This year, NEET का student scored 92 रे. Medical students scored 92 in JEE mains. So let's see. Get full marks, na Divyanshu. That's a good score. Right? Get full, na? Get as much as you can. How to do this thing? See, I'll give you more general one, okay? Rho r power n. I'll show you for r power n. So consider a Gaussian surface inside. Story is the same. So for r less than equal to r, the flux will be integral E dot surface area 4 pi r square. Left side, there's no problem. This is charge enclosed by epsilon. Now, what is charge enclosed inside? Now, this is a problem. Means you want the charge up to small r. So, in small r, at a distance x, take a thin shell. So, इसमें the charge dq will be density rho into surface area 4 pi x square into dx. Do you agree? If you take a thin shell at a distance x, the surface area 4 pi x square into dx will give you the volume into rho. So this will be 4 pi rho naught. That will be x power n plus 2 into dx. So if I integrate this, I get 4 pi rho naught integral x power n plus 2 dx from 0 to r. 4 pi rho naught n plus 2 x power n plus 3. So if I substitute here, we get E into 4 pi r square will be 4 pi rho naught by n plus, this is n plus 3. N plus 3 r to the power of n plus 3 by epsilon. 4 pi will cancel. We end up with E is equal to rho naught by epsilon n plus 3 by n r to the power of n plus 1. So E is proportional to r to the power of n plus 1. You're getting it? So remember this result. Huh? If rho is equal to rho naught into r power n, then we get field is proportional to r power n plus 1. It is always n plus 1. Keep that thing as a thing. So if you put x is equal to capital R, we get total charge. That is 4 pi rho naught n plus 3 r to the power of n plus 3. So for r greater than equal to r, E is equal to k q total by r square. You just take it as a point charge in the center. This is a very important result. I'll write it in the question only. E is proportional to r power n plus 1. When rho is equal to rho naught r power n. If your charge density goes as a function of power n, and this will go as a function of n plus 1. Good result, remember this. Clear with this? Clear? Next one. So that's about cylinders and solid spheres, and solid sphere may also variable charge density. Infinite sheet. Let's see, if you have an infinite sheet and you want to find the field, do you remember the result for infinite sheet? हमने derive किया था. What? Sigma by 2 epsilon. So how do we derive this? Consider a Gaussian surface like this. You're getting it how? You take a cylinder and push it through the sheet. Then if you look at here, this is the charge enclosed. The Q enclosed will be sigma into area. So in this case, the field will be E this way. Field will be E this way. The flux on the cylinder will be flux on the two discs. Disc to the right, flux due to the disc due to the left, plus flux through the curved part. This is 0 since E is perpendicular to A. Because this time field will be this way, but the area vector is this way for this cylinder. This is the area vector and this is the area vector. So we get E into A. Remember, the scalar quantity just adds up. The total flux is 2EA. This is equal to charge enclosed by epsilon. Charge enclosed is sigma into area. E will be sigma by 2 epsilon. This is the same result we got for a. उसमें क्या किया था हमने फिर remember? We calculated field due to a disk and then we kept R infinity. No integration, nothing. The same result if I do for an infinite plate. The difference between a sheet and a plate is plate has a thickness. That means there are two surfaces. That means the field here will be sigma by 2 epsilon ka 2 times. Sigma by epsilon, sigma by epsilon. So whenever you have a sheet is simply a single, means when you see from the left side or right side, you're seeing the same molecule. Sigma by 2 epsilon, sigma by 2 epsilon. This is another result which you need to remember with infinite sheets. Have a look at this. Clear? So the field will be away from the sheet and parallel to the, parallel. It is constant no matter how far you go. The field is always constant for an infinite sheet. Clear this? Arushi, got this? Let's see a question. Remember the result sigma by 2 epsilon. So can you do what to with this thing? I have two infinite sheets like this. This is an XY plane. This is a YZ plane. On this sheet, the charge is plus sigma. On this sheet, the charge is negative, minus 2 sigma. And there are 4 points here, A, B, C, and D. Right, so we have two infinite sheets along XY and YZ plane. Find the field at ABCD, vector components, I cap, J cap. Again, remember, whenever you have an infinite sheet, how is the field? If this is your sheet, if this is plus, the field will be away from the sheet. Suppose if this is a sheet and if this was minus, the field will be towards the sheet. So you just find the field due to each sheet and just add them vectorially. The best question would be this thing, draw the field lines. What's a question? They'll give a question like this, they'll give you 4 diagrams and they'll ask you to draw the field lines. Let's do both. Show you. See. So due to this red one, the field will be away. How much? Sigma by 2 epsilon. Here it will be down. Sigma by 2 epsilon. Down. Sigma by 2 epsilon. Up. Sigma by 2 epsilon. The green one will attract towards itself. So it will be this way. It is minus 2 sigma by 2 epsilon. 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 Make sense? हो गया ना I cap J cap. If you see, all have same magnitude. But now, if you look at this angle, na, what is this angle theta? Tan theta opposite by adjacent side, you're getting half, na? Isn't it? So if you actually draw the field lines for this, you know how it will look? So you're making an angle of tan theta half. The field lines will go from positive to negative, right? So this is how the field lines will look. This is how the field lines will look. You getting? Where this angle tan theta is equal to half. So you have a uniform field and the field goes from positive to negative plate. So they'll form kind of like a rhombus. This is the field lines. Sure, everyone? Equipotential कैसा होगा? How will equipotential look like? Do you remember for equipotential surfaces, field is perpendicular. This is how equipotential looks like. It looks like a cross passing through the center. Isn't it? These are equipotentials. The black ones are the field lines, the red ones are the equipotential. But yeah, you got the idea there. Clear? Equipotential will look actually more interesting, meaning the equipotentials would look like this. This is how they look equipotential. These are equipotential surfaces. Perpendicular to the field lines. Clear? There. So next time if you're drawing some rangoli or something, quite helpful. Just put some two different plates and finish it off. You just start drawing field lines and people will think like what a design. Clear? Then. So there we saw all different shapes there. Infinite sheet, infinite plate, और क्या बच गया? Cylinder. Yeah, I think those are all general shapes. Okay. Next thing. You got a little bit of theory. So listen carefully. It's again all theoretical. Field inside a conductor. See, simple concept, but let's see how this works. Let's say if you have a conductor and you put a plus Q charge outside. Inside you have a lot of electrons. What will happen? They'll get attracted. Right? The free electrons will get attracted. Listen carefully. The concept is important because some of the questions will be based on this theory only. Now, because they're getting attracted, what will happen? This side will start becoming negative. This side starts becoming positive. So on the electron in the middle, now there are two forces acting. One, let's make this green color. The induced forces are attracting this way. The electrons here, they're repelling the electron back, but the positives here are attracting the electron here. And this plus guy is still attracting. But initially, the force due to this capital Q is greater than the induced. Suddenly, you can't balance. Since the force is greater, more and more electrons will continue to accumulate.
So can you explain that F induced ones?
So we have charges here, na? Because of this electron, this side will become negative. The negative will repel this electron. This positive will attract this electron. So the forces will be right side, na? Induced forces ka. Right?
Means जो बीच में होंगे वो कहीं भी move नहीं होंगे.
They're moving there still. They're still moving, na? The force is more. Then what will happen? Because more and more electrons are going, at one point you have induced so many electrons here, so much charge induced हो गया यहाँ पे. You're getting this is an intermediate stage. अभी तक steady state आया नहीं. हाँ Shaurya?
Yes,
This
sir.
becomes so much plus here. Plus Q. Now what will happen to this electron here? This induced charges का force and this electrostatic attraction का force both become equal. No? FQ becomes equal to F induced. So if I ask you this question, is plus Q attracting the electron? Yes. Is induced charge attracting the electron? Yes. But is the net force is there? No. Net force is 0.
So can you
Net
explain
force
the
and
third one
electron.
again?
See now, as the electrons are accumulating more and more, what will happen? There'll be a lot of high charge here. So this induced forces ka charge will become equal to the external force ka charge, external charge ka force. So at that point, you reach a steady state, right?
So won't there be attraction between the induced charge and the plus Q1, means minus of the induced charge?
वो ठीक है ना रे, we are talking about electron inside the conductor, वो तो होगा. We are talking about an electrons inside the conductor. We are not interested in दोनों का बीच में क्या होगा, attraction होगा. So the whole thing will try to go. We are not interested in that right now. But are you getting the point here? Think of the story like this, huh? We have a room here. We have another room here. Okay, I'm standing here. And what am I doing now? Let's say there are some people in this room. There are some people in this room. Whoever comes here, I'll catch them and throw them into this room. Think of it like that. Whoever is coming here, I'll catch them, throw them into the room. Initially, kya hoga? Nothing will happen. I'll throw one person, second person, third person. Let's say initially both the rooms have 100 and 100. After some time, this becomes 80 and 120. Do you think when I'm throwing the next person, these people will love it?
No.
So what will happen? They will start giving a force, right? They'll start pushing back, mata ho karke, don't come. And this guy also doesn't want to go now because there's more empty here. But still, I'm stronger. So kya hoga? I will continue to push. At one point, this will become 50 and 150. Don't you think this repulsion force, this resistance will increase more? At one point, this will become 40 and 160. The opposition is so strong, this opposition and this guy both become equal. I won't be able to push any more extra people into the other room, right? You're getting this logic here? Same thing is happening here. When this plus Q is attracting, I'm pulling more and more electrons, but यहाँ पे इतना load हो रहा है ना, so many electrons are here. This electron, when it comes here, they'll push him out. Don't come. It is too crowded here already. Is this making sense? That means the guy in the middle, right? The net force will be 0 on him. Na? So this guy who is stuck here, he'll have a net force 0. This person is pushing, the induced charges are pushing, both are cancelling out. Is that making sense? So since the net force is 0, the field is 0. So look at the diagram here. Therefore, field inside the conductor is 0. So this is an important statement. Right? Field inside a conductor due to static charge distributions, meaning if the charges are not moving, is always 0. No matter how much charge you keep. Let's think this way. If it is not 0, what will happen? If it is not 0, what will happen? If it is not 0, the electrons will continue to move. And they'll start accumulating. They will accumulate so much the field has to become 0. Logic समझ में आ रहा है? Think of like this. If the field is not 0, the electrons will go. Think like this thing. This is a conductor, and let's say field is not 0. What will the electrons do? Electrons will go in which direction? Opposite to the field. So electrons will go this way. So this will become negative. This will become positive. They will create a new field. Na? This field and this field will cancel, right? Logic समझ में आ रहा है? If the field is not 0, the electrons will continue to move. They'll keep on going, keep on going, keep on going till the induced field and the outer field will cancel out. So you can never have a field inside a conductor. This is the whole concept of something called shielding. That means if I put you in a metal box, right? And if I put no matter how much voltage I keep, 10,000 volts, 20,000 volts, nothing will happen to you inside. The same way, kabhi dekha, when you go into the lift, phone ka signal 0 ho jata hai. When you go into a lift, why does your phone ka signal become 0? Phone is an electromagnetic signal. The field lines don't enter inside. your phone ka signal becomes 0. Your lift is a conductor. If the lift is having some holes, or that, remember that lift aata hai wo grill wala with holes, in that you get the signal. But if you have this escalator with doors closed, completely your signal becomes 0, or your signal becomes pretty weak.
Sir, sir, then in electrostatics, you prove that inside the hollow sphere the electric field is 0 by taking any point. So is that similar?
In what case does this look similar, Shravya? ये
No,
sphere जैसा लग रहा है क्या?
नहीं, पर उसमें भी inside the sphere वो electric field 0 था ना. So मैंने कुछ तो लॉजिक होना चाहिए ना. It is 0 तो it is same. So you mean to say a cat and a lizard are same because both have 4 legs. How do you feel about this statement? A lizard is nothing but a baby cat because it has 4 legs. Legs same है ना? हाँ शौर्य? नहीं. चलो. A human has 2 legs. Cat has 4 legs. Therefore, a human is a half cat. कैसा लगा explanation? तो वही बोल रहे हो ना, just because bloody they have 4 legs, you are saying everything is same. Field 0 था hollow sphere में. Logic क्या था उसमें? Every point का charge is cancelling out because of this, this area and this thing is same. यहाँ पे I gave you some random conductor and I proved E is 0 inside. तू कुछ भी चिपका रहे हो, पता है concept? Any concept को चिपका रहे हो. Meaning, you just have to remember and you'll stick it anywhere. You are actually behaving like a Hindi movie का story writer. ये बॉलीवुड में स्टोरीज ऐसा ही होता है. स्टोरी यू लिसन 15 minutes, then next 15 minutes you don't understand relation क्या है दोनों का. Hero is going and killing everyone in the harbor, right? Audience are thinking ये क्यों मार रहे हैं, मतलब कुछ लॉजिक नहीं है. मतलब हीरो इज स्ट्रांग तो उसको सिक्स पैक दिखाना है ना, तो इज गोइंग एंड बीटिंग एवरीवन. So you don't come up with this innovative theory concepts, रे शौर्य. कुछ भी वही में भी मत चिपकाओ. You are just taking everything. Are you getting it? E is 0. I agree with that fact, but the reason why it is 0 is 2 different reasons. Are you clear? No, sir. The reason we proved
ठीक है, हम क्लास के बाद फाइट करते, छोड़ दे. Remaining people are getting disturbed. If we continue like this, Arushi will beat you and me. She will accept maybe fees pay किया, मुझे भी कुछ बताओ. So let's continue. But anyway, did everyone got the idea here? So if you put a conductor in a field, no matter what you do, field inside will be 0. That means this is the final diagram it looks. If you have a conductor and if you have a charge Q, the field lines from here, now, this is important. They did ask something like this. The field lines will be like this. The field lines will enter the conductor perpendicularly and will leave the conductor perpendicularly. Inside there are no field lines. This is your induced charge. Let's call it minus Q and let's call it plus Q. This is how the field line diagrams will look. So the statement say, can you tell me why it is entering perpendicularly? Always perpendicular. The field lines are always perpendicular to the surface. Since field is 0, what kind of surface it is? It is equipotential, na? Remember, E is equal to minus dV by dr. If E is 0, V is constant. So if E is 0, dV by dr, V is constant. Therefore, conductors are equipotential. So tell me something. Let's say you're going in a local train. Happened actually. They're going in a local train, and for some reason, right, the upper 10,000 volts ka high voltage cable, that is 10 kV ka line. Normally trains they get a power supply of 10,000 volts to 25,000 volts ka power supply. So कुछ accident हो गया था, and one of the 10,000 kV volt ka wire, right, fell on the compartment.
You're in the compartment, sitting and watching outside. Train stopped, right? People started shouting, jumping. Everyone is doing everything. What will you do? Option 1, just sit inside and chill out. Abhi the high tension cable is there, fully active. Option 2, start running, shouting and jumping outside the cable, right? Option 3, aram se put one leg outside, one leg inside and then come out. Option 4, right? Just call up everyone, all your friends and put photos in Instagram. What will you do?
सर चिल आउट सर, अंदर कोई इलेक्ट्रिक फील्ड ही नहीं आएगा ना बॉक्स के अंदर, आपने बोला.
What do you guys think? Problem क्या ना, I'll tell you one thing. See, you don't die because of potential. You die because of potential difference. When you're sitting inside, the entire compartment का voltage became 10,000 volts. Okay. So when you're touching your leg, इसका voltage कितना था leg का? 10,000 volts. If you touch the compartment, what is the voltage? 10,000 volts. What is the potential difference? 0. That is the reason na, when a crow is sitting on a high tension cable, it doesn't die. That doesn't look like a crow, but yeah. So when a bird is sitting on a high tension cable, why doesn't it die? Because your wire jo hai na, both the points of potential is same na. That's why birds don't die when they sit on that high tension cable. You're getting it? When will you die? If you put one leg outside on the ground and one leg inside, ground ka potential kitna tha? 0. This ka potential 10,000 volts. Now you're going to get a bad shock. Bad matlab you'll get fried actually. 85% of the deaths that happen due to electric shocks are due to third-degree burns. So that is the most useless thing you can do. Shut your mouth and sit inside. Let the railway people come and take the cable and pull you out. Fir bhi, for some reason you have to get out. Jump with both the legs outside. When you're leaving the compartment, make sure you're not touching anything. When you're on the ground, make sure you're not touching anything. So when you're jumping ek saath, just jump outside together and make sure you're not touching the ground and the compartment at the same time. By any chance you touch both of them, you're gone. That is the second best option. Sitting is best. Jumping is second. Instagram is third. Putting one leg outside is the worst.
Sir,
actually, Instagram should be second. हाँ शौर्य बोलो. शौर्य will बताया बोलेगा मुझे Instagram account नहीं है मैं क्या करूँ. That is a doubt. I can't do anything. You can put in Facebook रे चलेगा. बोलो, you had some doubt. What?
Sir, if it is in air and one on train, then there will be.
कुछ नहीं होगा रे. Air is insulator. Air पे air is insulator. कुछ नहीं होगा. Right. Now remember one thing, for equipotential surface, how will the field lines enter? The field lines always perpendicular. The field lines always enter and leave the conductor perpendicularly. Clear? Here I have one more question, Ray. Can you tell me which charge is bigger? Is Q bigger or induced charge bigger? Which charge is bigger? Is Q external bigger or the induced charge bigger?
Q external.
Why? Reason? They're not same. Can you observe something here? How many field lines are there? 1, 2, 3, 4. This is 5, 6, 7. Who has more field lines? Capital Q. Whoever has more field lines will have more charge, isn't it? Do you remember that concept? Q external has more field lines. Because see, every field line minus Q will get has to come from capital Q. But capital Q, all the field lines won't go into the conductor. Some will go to the left hand side also. The number of lines of Q external is more. Therefore, Q is greater than small q. Just a small theoretical question. This thing is clear, everyone. Now, there are few cases. Let's see them. Like I said, it's all just theory only. Listen carefully. They're not difficult, but you should know. You have a conductor, solid conductor. Okay? And someone gave a charge Q. So now you want to find how will this charge distribute? Will it go inside or will it be outside? Exactly kya hoga? So you have a solid conductor and you give a charge. Let's assume some charge is gone inside, okay? So let's assume we have a Gaussian surface. Consider an imaginary Gaussian surface. Now, tell me one thing. What is the field inside the conductor?
0.
0. So what is the flux?
0.
0. Therefore, what is the charge enclosed?
0.
0. Matlab, there should be no charge inside the conductor, no? So if you give a charge Q to a conductor, there can be no charge in the bulk of the conductor. So because of this, what will happen? If you give a charge Q to a conductor, all the charge will be on the outside only. It will not go inside. Is that making sense? But let me give you a better logical way. A Gaussian surface thoda mathematical tha. Think of like this. When you're putting plus charge, what are you doing exactly? You're just dumping a lot of positive charges, right? Let's say in a room, you and your enemy is there. Your enemy is your sister or brother who is eating your cake. Right? There are 2 cupcakes, one for you, one for your brother or sister. You came home from the class, excited to eat the cupcake. You went to the fridge and opened it, dono missing hai. Right? When you actually inquire about it, you find both the cupcakes with your brother eating, sitting and enjoying it. Then what do you do? If you hate your brother or sister, what do you do? Both of you in the room, will you both sit together? You will just try to sit as far as possible, isn't it? So same way, when you have like charges, when they repel, you try to be as far as possible. Now, if you dump a lot of like charges, what will happen? They will all repel each other till they go the farthest. What the farthest you can go? Surface, right? That's why no one will be staying inside. Is that making sense? You'll not forget this, obviously. Your brother ate the cupcake. See, those are the kind of things you'll never forget in life. So, but I hope the case one is clear. If you have a solid conductor and if you give a charge Q, the charge will never be inside, it will always fly off. Clear? Case 2. Now, same thing, we'll be just playing with different cases. So basically, charge cannot exist inside the conductor. I'm not talking about cavities, huh? Conductor, proper metal mein you can't keep the charge inside. You try to put the charge on a conductor, it will just try to fly outside. Case 2. What if you have a conductor with a cavity? And I'm giving charge Q. So abhi doubt ye hai, can some charge go and stay inside? Do you think that is possible? Again, think logically. If you have a charge Q and Q here, they will repel each other. They'll go over to the surface again, no? When you can go to the outer surface, why you want to stay in the inside surface? So again, you can, so if you have a conductor with a cavity and if give a charge Q, again, same story. All the charge will be on the outer surface. There's no charge inside. Again, you can prove this. Take a Gaussian surface. Right? Field is 0. Flux is 0. Therefore, Q inside is 0. So you cannot have any charge inside the cavity. So no charge inside the cavity. if you give it from outside. These are all different possibilities that can happen. Is case 2 clear, everyone? Case 3. What if you have a conductor, you have a cavity, and this time you keep the charge here. You place the charge inside the cavity. Now what will happen? What do you think will happen? What will this guy do? This plus will start attracting all the electrons, right? So all the electrons will start coming closer here. That means you get the vacancy on the outside. Is that making sense? So let this charge be minus Q. That means the outside charge will be plus Q. We don't know how much charge is induced. Now consider a Gaussian surface here. Field is 0 because it's a conductor. That means flux is 0. That means charge enclosed Q minus Q is 0. That means Q is equal to capital Q. So whenever you keep a charge Q inside a cavity, it induces equal and opposite charge. Because there is no way for the field lines to escape. This is an important result. It doesn't matter what kind of shape you take. You take any random shape, you take any random cavity, you take a conductor. Keep this in mind. If you put a plus Q charge, you will induce a non-uniform distribution yahan pe because it's not all symmetry. But this charge will be minus Q. Because the conductor is neutral, to conserve charge, the outside charge will become plus Q. Is that clear, everyone? So let me draw that again. So this is a neutral conductor. There is no charge. And let's say you kept a charge Q here. So because of this plus Q here, you will start inducing charges. The closer points will have more charge. This will be minus Q. Outside will be plus Q because the outside is neutral. Clear? This will be non-uniform distribution because the surfaces are non-uniform. There's no symmetry.
Sir, in this case, what will be field in cavity we can find?
We can't find na. Non-uniform charges के लिए calculate नहीं कर पाएंगे. Clear? If I give one more example, it kind of looks like this. If I take a proper sphere with a sphere, let's say if I take one more sphere and one more sphere. Can you tell me how this guy will look? Let's say I keep a charge Q1 here, and let's say keep a charge minus Q2 here. Can you tell me how will the field distribution look like now?
Half sphere will be minus plus.
See what will happen. This plus Q1 will induce negative charge here. This will be more negative because it is closer. Minus Q1 hoga. This minus Q2 will induce more positive here, non-uniform. And this will be plus Q2. Total outside will be how much? Q1 minus Q2, na? Now we don't know which is bigger. If Q1 is bigger, it is positive. Q2 is bigger, it will be negative. Got this? And how will the field lines look like? You will see something interesting here. If you look at the field lines, this green ka field lines will be like this. Negative charge, no? Let me draw it in the next page. The field lines will look like this. There is something I wanted to show you here actually. This minus Q2, this field lines will be like this. Right? This field lines will be like this. They'll be more clustered here. Remember, they'll always enter perpendicularly, no matter what. And the outside field lines will be uniform because outside is uniform sphere. Did you observe one thing? Do you remember what is field definition? Two charges interact with each other because of field lines. If there is one charge Q1, the other Q2 knows that you exist because of field lines. Are the field lines due to Q1 coming out? They're completely blocked inside, right? Because field to zero tha yahan pe. That means no one outside will know that Q1 is existing inside. Is this making sense? The field lines due to Q1 are not coming out. They're blocked by the conductor. That means Q1 does not know minus Q2 is existing. Minus Q2 does not know Q1 is existing. Are you getting this? The field lines due to Q1 and minus Q2 are blocked by the induced charges. That is the outside systems, right? So charges outside the sphere are unaffected by Q1. That means Q1 को कितना भी move करो अंदर, कुछ effect नहीं पड़ेगा. You move Q1 how much ever you want. Outside charges don't know. Charges outside the sphere right? Do not even, what do you call that? Do not even know that Q1 and Q2 exist. Are not affected by Q1 and minus Q2. Itna Q, Q1 does not know minus Q2 exists. Q1 and minus Q2 also do not interact. Do not know the other one exists. This phenomena is called shielding effect. Where did you learn this? Chemistry. The electrons in the 1s orbit, right? When the electron is jumping from these higher orbits, the shielding effect. Yeah? So when electron is doing a transition from a higher to lower orbit, let's say electrons are already there in 1s, 2s and everything. Someone is jumping from 4s to 2s. The electrons in the third shell will repel that, no? They interfere with the motion of that. It's called shielding effect. This phenomena is called shielding effect. Are you getting this? So this is what I was saying. So when you're inside a lift, this is what happens. The outer signals won't come inside. Your signal will not go outside. So this is one of the best places. So if you can put yourself in a big metal box and sit inside, you're unaffected by everything. Not a single electromagnetic wave enter inside. You won't get any signal. This is the reason why your Wi-Fi gets stopped. If your Wi-Fi is 2 rooms away, it gets blocked. You know why? Because your entire, this pillars and all, you have a lot of interference actually. 4G still works, 5G doesn't work. 5G is a very high frequency. For high frequencies, right, if you have even a one single wall, the frequency will drop drastically. So if you're using a 5G Wi-Fi or a 4G Wi-Fi at your house, you'll observe 4G has 4 point signal, the 5G has only 1 point. So 5G has to emit a lot of energy. Okay. Anyway, so with this, we'll wrap up for the day. So this is a Gauss law. So make sure to revise. There's a bit of a theory. If you see, the questions are not numerical, if you observe. It's all statements, aisa hua, to aisa hua and all. So next class when we meet, right, tomorrow, I was thinking tomorrow we need to, I wanted to ask you also a few things actually. One,